Hello everyone, welcome to DEEPTHI Academy. In this video, I will bring to you some of the important MCQ on light, reflection and refraction. This is according to the new pattern for term 1 examination 21-22 academic year. So let's start the video. Here is the first question. Beams of light are incident through the holes A and B and emerge out of box through the holes C and D respectively, as shown in the figure. Which of the following could be inside the box? So here we have one beam of light which is going to be incident through the box. So here is the box, and this box is having the holes A and B. So through the holes A and B the light is going to be incident, and through holes C and D the light is going to be emerge out from the box. So the question is here, inside the box what we have? We have option A, a rectangular glass slab, convex lens. Option C, we have a concave lens, and option D, we have a prism. So here the first option A, that is a rectangular glass slab. You can see here, so whenever the light is going to be travel from one medium to the another medium, the light is going to bend. So here inside the box we have a rectangular glass slab, because a lens, you know how it is going to be refract, and even for the concave also, and this kind of refraction bending of light will not be shown by the prism also. So the answer is rectangular glass slab. Next question. Which of the following statements is true? Option A, a convex lens has 4 diopter power having a focal length 0.25 meter. Option B, a convex lens has -4 diopter power having a focal length 0.25 meter. Option C, we have a concave lens 4 diopter having a focal length of 0.25 meter. And option D, we have a concave lens has -4 diopter power having a focal length 0.25 meter. So out of 4 options we have to be choose the option which is true, which is correct. So let's study one by one option. So we have a convex lens 4 diopter. So first of all, you just you know that power, if the power that is in plus diopter, which means the given lens is convex. The given lens is convex. If the power is negative diopter, it means the power is negative. The given lens is concave, as we know. Okay, so here we have an option A. So just cross check for the option A. So the lens has 4 diopter power. So we know the formula, P is equal to 1 by F, right? And here we have 4 diopter. So power we have 4 diopter is equal to 1 by F. Okay, so therefore F is equal to, I can write here 1 by 4, and therefore it can be written as F is equal to 0.25 is the answer. Okay, so for the first option you are getting the power 4 diopter, and for focal length you are getting the answer 0.25 meter for the first option. Okay, now let's cross check for the option second one. Okay, let us cross check this one for second one. So second one, we are having a convex lens has -4 diopter. So convex minus 4. So we know that the power for the convex is always positive. So here in the option B they have mentioned minus 4 diopter. So which means this option B is not true. Got it? Similarly, check for the option C. A concave lens has 4 diopter. So plus 4 diopter. So concave, the power should be negative. But here they have mentioned positive. It means this option C is also false. So let us check for the option D. So here a concave lens has minus 4 diopter. And power having focal length 0.25 meter. So here as the power they have given minus 4 diopter, it's correct, but the focal length it should be also in minus, but here they have mentioned in 0.25 meter plus they have mentioned. It means this option is also wrong. So here the option A is the correct answer, that is a convex lens has plus 4 diopter and having the focal length 0.25 meter, that is plus 0.25 meter. Next question. Rays from sun converge at a point 15 centimeter in front of a concave mirror. Where should an object be placed so that same size of its image is equal to the size of the object? So here we have a concave mirror, right, that is bulging inwards, and here the rays are coming from the sun and they are converging at the point 15 centimeter in front of a concave mirror. Okay, so let's suppose that here we have a center of curvature and here is the focus, and all the refracted rays are converging at the point F, and the distance from the pole to the focus is 15 centimeter. Okay, so here they are asking the question that in order to get the same size of the image as the size of the object, so where should be the object should be kept? So as we know from the ray diagrams, in order to get the same size of the image of the object must be placed at the center of curvature. Okay, in order to get the same size of the image, the object should be kept at the center of curvature, right? So here in the option we have the object 15 centimeter in front of the mirror. No, object should not be kept at the 15 centimeter from the mirror. And option B have 30 centimeter in front of the mirror. So here, as I told you, from pole to the focus we have 15 centimeter. So from focus to the center of curvature it is 15 centimeter. So total 30 centimeter. So here, in order to get the same size of the image of object, the object should be kept at 30 centimeter from the pole. So option B is the correct answer. Next question. A full length image of a distant tall building can definitely seen by using. So here we have a full length image of a distance tall building. We have one tall building that can be seen by using. So here we have a option concave mirror. So concave mirror, we know that depending on the position of the object, the concave mirror, it is always going to produce a real and inverted image, and also it is going to produce a diminished, highly diminished, same size and enlarged. So always full length image cannot be seen by using the concave mirror. So option A is wrong. So let's move to the option B. So option B, convex mirror as we know that convex mirror, it's going to produce the image which is always virtual image, and it's like the image is going to form behind the mirror, right? And the size is diminished. Okay, so let's check for the option C also. Option C, like we have a plane mirror, and plane mirror is going to form the image of the object at the same size, same distance from the mirror, but always cannot be seen the full length, because in order to get the full image by the plane mirror, the size of the plane mirror should be half of the object. Then only the plane mirror we can see the full image of the object. So this plane mirror, option C, is also wrong. And here we have both concave. So as concave, in the sense we cannot see this one. So here option B is the correct answer. That is, by using a convex mirror, we can see the full image of a tall building only by using the convex mirror. So here option B is the correct answer. Next question. The angle between an incident ray and the plane mirror is 30 degree. The total angle between incident ray and reflected ray will be equal to, that is option A we have 30 degree, option B have 60 degree, option C we have 90 degree, and option D we have 120 degree. So here, in order to solve this one, let us understand this one question first by drawing the diagram. So here we have a plane mirror. Okay, so we have one plane mirror. So I will consider one plane mirror. So let us suppose that this is the normal. Okay, so the angle between an incident ray and the plane mirror. So this angle between the incident ray and the plane mirror is 30 degree, right? So this is the incident ray. So whenever the light is going to incident on the plane mirror, it gets reflected back, right, according to the reflection of light. So here, so this total angle degree is 90 degree. So as the angle between plane mirror to the incident ray is 30 degree, which means this angle is equal to 60 degree, right? And as per we know that the laws of reflection, the angle of incidence is always is equal to angle of reflection. So here this angle is also 60 degree, right? And here this angle, it is 30 degree. Now in the question they have asked that the total angle between the incident ray, this incident ray, and the reflected ray. So this total angle is equal to how much? So here this is 60 degree, right, and this is 60 degree. So total it is 120 degree. So here we have the option D, 120 degree is the correct answer. Next question. A ray of light is incident on a plane mirror making an angle 90 degree or with the mirror surface, right? The angle of reflection for this ray light will be, so what is the angle of reflection? So here we have the option A 45 degree, option B 90 degree, option C 0 degree, and option D 60 degree. So let us consider here one plane mirror, right? So here this is the normal. Okay, so a ray of light is incident on a plane mirror making an angle 90 degree. So which means the ray of light is going to be incident to the normal. Okay, now the question is the angle of reflection for this ray is equal to how much? So here as the angle of incident is 0 degree, right? As it is going to be incident through the normal, so the angle of incidence is 0 degree. Obviously the angle of reflection is also 0 degree, correct? So here we have option C, 0 degree is the correct answer. Next question. The image of an object formed by a plane mirror. So what is the image of an object formed by a plane mirror? That is, as we know, it is going to produce a virtual image, because real image diminished upside down will not be produced by the plane mirror. Plane mirror, it will produces the virtual image. So option A is the correct answer. Next question. The image formed by a plane mirror. So option A, we have virtual behind the mirror and enlarged. No, enlarged image will not be formed by the plane mirror. Option B, virtual behind the plane mirror and of the same size as the object. Okay, so this is just true. Option B is true for the image formed by the plane mirror. Now just check out the next options also. Real at the surface of the, no. Option C is not correct, because plane mirror, it is produces virtual image, and option D also they have mentioned in real, so option D is also wrong. So only the option B is correct, that is virtual behind the mirror and of the same size as the object. Next question. The figure given alongside shows the image of a clock as seen in a plane mirror. The correct time is. So here we have a image of a clock that is shown by the plane mirror, and we have to choose the actual time. We have the time that is 2:25, 2:35, 6:45, 9:25. So here, so I will show you the image. Look at here. So here we have kept the, here we have taken a plane mirror, and in front of a plane mirror we have kept a clock. Okay, and the image of the clock is going to be produced by the plane mirror behind the mirror. So you can see here in the question, what is that one time? It is 2:35. Okay, this image is 2:35, the image of the clock shown by the plane mirror. But here we have to choose the answer, that what is the actual time. So here the actual time is, it is 9:25. Actual time is 9:25. So here I have just explained you by using this image. You can try it by yourself, like take a plain paper, and whatever the image formed by the plane mirror. Okay, if you wanted to know the object, the clock plane mirror, you have to draw the that same clock. Now you draw this one time. You just draw on a plain paper this clock and reverse it, and reverse that one and see the time. You will see the image formed by the plane mirror. So in order to check the image formed by the plane mirror, you can draw any object, anything you take, just turn the page, so that image will be the image formed by the plane mirror. So this idea we need to keep in our mind. Next question. The focal length of a spherical mirror of radius of curvature 30 centimeter. So what is the focal length we have to calculate? So here we know the relation, that the radius of curvature and the focal length, that is r is equal to 2f. So here they have mentioned the radius of curvature is 30. This is equal to 2f is as it is. Therefore f is equal to 30 divided by 2. So this is equal to 15. So here the focal length of a spherical mirror of radius of curvature 30 centimeter is 15 centimeters. So here option B is the correct answer. Next question. The real image formed by a concave mirror, the real image formed by a concave mirror, larger than the object. It is larger than the object when the object is. So here we know that the concave mirrors will produces the diminished image, large image, and also the same size. So here, in order to get the enlarged image, where should be the object kept in front of a concave mirror? So here we have the option A, at a distance of equal to the radius of curvature. No. So whenever this is like, if you have kept the object at a distance of equal to the radius of curvature, you will get the same size of the image. So option A is not correct. And here at a distance less than the focal length. No. So here if you have kept the object less than the focal length of a concave mirror, you will get the image virtual and erect. So here they have mentioned real. So option B is also not correct. And option C, here we have between focus and the center of curvature. So here when the object has kept in between focus and the center of curvature, yes, here you will get the enlarged image. So let's cross check for the option D also. At a distance greater than the radius of curvature. So at a distance greater than the radius of curvature, here this option D, this is like if you have kept the object greater than the radius of curvature, that is beyond C. So if you have kept the object beyond C, the image is formed a diminished image. Okay, the image is diminished. So but here they have asked enlarged. So here option D is also wrong. Only the option C, that is when the object has kept in between focus and the center of curvature, you will get the enlarged image. Next question. The real image formed by a concave mirror is smaller than the object. The image should be smaller than the object if the object is between the center of curvature and the focus. So here we have kept the object between center of curvature and the focus. The image will be not the smaller image. Okay, so option A is not correct. And option B, we have at a distance greater than radius of curvature, greater than the radius of curvature. So greater than the radius of curvature, if you have kept that one, so it means beyond C, the image is small, that is diminished image. So here option B is just related to the question. So let's check for the option C also. At a distance of equal to the radius of curvature. No. If you have kept the object that is equal to the radius of curvature, that is at the center of curvature, so the same size image is formed. So smaller image will not be formed. So option C is also wrong. And option D, that is at a distance equal to focal length. So equal to focal length, if you have kept the object, the image is not going to form the smaller image, is a enlarged image is formed. So option D is also not correct. Here we have the option B is the correct answer, that is the distance greater than the radius of curvature. That is, if the object has to be kept beyond C, then you will get the image, the smaller image. So option B is the correct answer. Next question. The image formed by a concave mirror is real, inverted, and highly diminished. Each smaller than the object. The object must be. As we know that the image formed by the concave mirror highly diminished means that is the object should be kept at the infinity. So if you have kept the object at infinity, you will get the image is highly diminished. So no need to be cross check all these things, that as we know the concave mirror, it will produces the image highly diminished if the object has kept at infinity. So option D is the correct answer. Next question. In the concave reflector of a torch, the bulb is placed. Option A, we have between the pole and the focus of a reflector. Option B, at the focus of the reflector. Option C, between the focus and the center of reflector. Option D, at the center of curvature of reflector. So here, in order to get the concave reflector torch, the bulb should be kept at the focus of a reflector. See, if we have kept the bulb between the pole and the focus, so as we know from the ray diagrams, if we have kept the object between pole and the focus, the image is going to form like behind the mirror. Okay, and you can see the option C, between focus and the center of curvature. So if you have kept the object between focus and the center of curvature, so the image is going to form at like larger distance. So this is also not correct. And option D, at the center of curvature. At the center of curvature also there is same size the image is going to form. So only the option B, if you have kept the object at focus, the concave reflector torch, it will converge at larger distance. So option B is the correct answer. Next question. The focal length of a small concave mirror is 2.5 centimeter, right? In order to use this concave mirror as a dentist mirror, okay, as a dentist mirror, the distance of tooth from the mirror should be. So what should be the distance of tooth from the mirror? So in order to simplify this one, I will draw a diagram. So this is what a concave mirror, that is the dentist mirror. It is also called as a dentist mirror because it is used by the dentist. Okay, now we have the focal length of a concave mirror. We have a focal length 2.5 centimeter. So let us suppose that here is the focus and this is the focal length, which is 2.5 centimeter. Okay, it is 2.5 centimeter. And in order to use this concave mirror as dentist mirror, the distance of the tooth and the mirror, so what should be the distance from tooth from the mirror? So what should be the distance? So let us check it, the options. Here we have at 2.5 centimeter. So if we have kept the distance of tooth and the mirror at 2.5 centimeter only, so here you cannot see the enlarged image, right? You cannot see the enlarged. So option, at the same size you cannot keep the object. Okay, so option A is not correct. And here option B, 1.5 centimeter. So 1.5 centimeter. So let us suppose that the distance between the mirror and the tooth is 1.5 centimeter. So as we know, whenever the object has kept in between focus and the pole, the image is what it's going to form by the concave mirror, that is virtual and erect and enlarged, right? Virtual and erect and enlarged. So here the option B is the correct answer. So let's cross check for the option C also, 4.5 centimeter. So here if you have kept the object at 4.5 centimeter, so it cannot be shown by the the enlarged. So option D is also not correct. Only the option B is the correct answer. That is, in order to get the real image, like the virtual image of a tooth, which is going to form by the concave mirror, that is virtual and erect. So the object should be kept between the focus and the pole. As we know that in order to get the virtual image by the concave mirror, the object should be kept in between focus and the pole. So only one distance, that is 1.5 centimeter, is the correct suitable distance in order to get the virtual and erect image. So option B is the correct answer. Next question. One of the following does not apply to a concave mirror. Does not apply to a concave mirror. This is because option A focal length is negative. Focal length is negative. Option B, image distance can be positive or negative. Option C, image distance is always positive. Option D, height of image can be positive or negative. So here we need to choose the option which is does not apply to a concave mirror. So here we know this is the concave mirror. Okay, so this is the focus, this is center of curvature. Now here let's check for the option A. Focal length is negative. Focal length is negative. So here the concave mirror, as the concave mirror is a converging mirror, so focal length is left side, so you will get focal length is negative. So here option A is correct, like the option is correct, it will apply to the concave mirror. Now option B, image distance can be positive or negative. So as the image is forming in front of the mirror and there is left side, only the image you will get negative. Okay, like image you will get negative as well as positive also. Why? Because the concave mirror, it will produces virtual and erect image also when the object has kept in between focus and the pole. So option B is also correct for the concave mirror. And option C, image distance is always positive. So here image distance always positive. No, image distance will not be always positive for concave mirror. Okay, because concave mirror, it will produces virtual and erect image when the object has kept in between focus and the pole. So option C is not apply to a concave mirror. So let's check for the option D also. Here the height of a image can be positive or negative. Okay, yes, obviously as the concave mirror is going to produce always real and inverted, and in one case virtual and erect, so the height, it may be negative, it may be positive. So option D is also correct, but here we have to choose the option which is does not apply to a concave mirror. So option C is not apply to a concave mirror. So hence the option C is the correct answer. Next question. In order to obtain a magnification of 0.6, that is minus 0.6 magnification, with a concave mirror, here we have a mirror is concave mirror, the object must be placed. So where we have to keep the object in order to get the magnification is minus 0.6. So here we have, let's understand this with the diagram. So here we have a concave mirror, right? This is focus, this is center of curvature. So for the option A, if you have kept the object at focus, right? So the image is going to form enlarged. So enlarged means it is more than 1 magnification. So option A is not correct. Okay. So option B, between pole and the focus. So pole and the focus, if you have kept the object, the image is going to form virtual and erect image. So here the magnification is more than 1. So option B is also not correct. And let's check it for option C, between focus and the center of curvature. So here we have kept the object between focus and the center of curvature. So here also the image is enlarged image, so the magnification is more than 1. So option D, beyond center of curvature. So here when you have kept the object beyond center of curvature, the image is formed between C and F, that is diminished image is formed. So diminished means the magnification is less than 1. So less than 1, here they have mentioned minus 0.6. So here option D is the correct answer. Next question. An object is placed at a larger distance in front of a concave mirror and of radius of curvature 40 centimeter. The image will be formed in front of the mirror at a distance of. So here it is a numerical question, and here what they have given, here we have to calculate the radius of curvature. right? Here we have to calculate the radius of curvature. So radius of curvature, we have the relation r is equal to 2f. R is equal to 2f, and it is 40 centimeter, and it is 2f. Therefore f is equal to 40 divided by 2. This is equal to 20. Okay, so f is equal to 20. So which means the focal length of this one concave mirror, it is 20 centimeter. So here we have option A, 20 centimeter is the correct answer. Next question. Linear magnification produced by a rear view mirror fitted in vehicles. So the magnification of a rear view mirror equal to 1? No, because equal to 1 means same size of the object. Less than 1? Yes. So less than 1, the image, that is the magnification of the image produced by the rear view mirror is less than 1. Okay, let's cross check for the option C also. It is more than 1. No, more than 1 means it is like the image of the object greater than like enlarged image. So enlarged image will not be shown by the rear view mirror. Okay, so option C is not correct, and you can check for the option D also. Can be more or less than, depending on the position of the object. No, not more than or less than. Only the magnification of rear view mirror, it is less than 1. So option B is the correct answer. Next question. Linear magnification produced by a concave mirror. So the linear magnification produced by a concave mirror, option A we have less than 1 or equal to 1, option B more than 1 or equal to 1, option C less than or more than or equal to 1, and option D we have less than 1 or more than 1. So here we have to choose the option which is correct for the concave mirror. So as we know that the concave mirror, it is going to produce sometimes smaller image, same size, and enlarged image. So here, so for the smaller image, that is less than 1. For the same size, it is more than it is like more than 1, like, or the for enlarged image it is more than 1, or for this same size is equal to 1. So here option C is the correct answer for the concave mirror. Next question. Magnification produced by a convex mirror. So here we have to check the magnification for convex mirror. Option A more than 1, option B less than 1, equal to 1, and more or less than 1. So as we know that a convex mirror, it is always produces the virtual and erect image, and it is always produces the diminished image, smaller size image. So the magnification more than 1. So more than 1, it is not the magnification of the convex mirror. And here less than 1. Yes, less than 1 is the correct answer, because convex mirror, it is produces the image smaller than the object. Equal to 1? No. More than or less than 1? No. So option B is the correct answer for the given question. Next question. Magnification produced by a plane mirror. So here the magnification produced by the plane mirror, option A less than 1, option B greater than 1, option C 0, option D equal to 1. So as we know that the plane mirror, it's the image formed by the plane mirror, it is virtual and erect image, and the image size is same as the object. So the magnification less than 1 is not correct. Greater than 1? No, not greater than 1. 0? No. So equal to 1. So same size of the object, the image is formed by the plane mirror. So option D is the correct answer. Next question. In order to obtain a magnification of -2, such a concave mirror the object should be placed. So where should be the object placed in order to get the magnification -2? So option A, we have between pole and the focus. So for the concave mirror, let us suppose that this is focus, this is center of curvature. If I kept the object between pole and the focus, okay, so the image will be virtual and erect. So magnification -2. So it's not possible for the option A. Now option B, we have between focus and the center of curvature. So when the object has kept between focus and the center of curvature, the image is formed beyond C and enlarged. So enlarged, it means the magnification is greater than 1. Okay, magnification is greater than 1. So option B is the correct answer. So let's check for the option C also. So option C, at the center of curvature, if you have kept the object at center of curvature, so same size of the image is formed at C only. So the magnification is equal to 1. So option C is not the correct answer. So for beyond center of curvature, so beyond center of curvature, the image is going to form between C and F and the smaller size, that is magnification is less than -2. So here option B is the correct answer. Next question. The image formed by a spherical mirror is virtual. The mirror will be, so what is the image formed by the spherical mirror is virtual. So here option A, concave. No, here concave, it will produces real and virtual also, like rect and virtual also. And convex, it will produces only virtual. Okay, convex, it will produces only virtual. And option C, here we have either concave or convex. Option D, metallic. See, as we know that here both the concave and the convex mirrors will produce virtual. So here option C is the correct answer. Next question. Whatever be the position of the object, the image formed by a plane mirror is virtual, erect, smaller than the object. The mirror then must be. The mirror then must be. So here plane mirror, it will produces the image virtual, erect, not the smaller than the object. Correct? So option A is just you delete that one. And concave, virtual, erect, and smaller than the object. No, here depending on the position, yes, obviously the concave mirror, it will produce the virtual also and erect also and smaller than the object, but not always. Right, so here option B is also not correct. And option C, here we have option C, that is the option C, convex. Convex mirror, it will produces always for all the positions, right? That is virtual, erect, and smaller than the object. So here option C is the correct answer. Next question. If the image formed is always virtual, then the mirror can be, so mirror can be always virtual, the mirror can be concave or convex. Always concave will not produce the virtual, so option A is not the correct answer. Concave, no, right, concave means it will not produce the always virtual. Delete that one. Option C, you check this one. Convex or plane, yes, convex or the plane mirror, they will always produce a virtual image. So option C is the correct answer. Next question. A concave mirror cannot be used as option A, a magnifying mirror, option B, a torch reflector, option C, a dentist mirror, option D, a rear view mirror. So the concave mirror, it can be used as magnifying because it is a converging mirror. A torch reflector, yes, it can be used as a torch reflector. A dentist mirror, yes, the concave mirror can be used for dentist mirror. This rear view mirror, so concave mirror cannot be used as rear view mirror. So hence the option D is the correct answer. Next question. A boy is standing in front of and close to a spherical mirror, right? He finds the image of his head bigger than the normal. He finds his head bigger than the normal, okay, and the middle part of his body of same size. The middle part of his body is same size, and his legs smaller than the normal. Okay, the special mirror is made up of three types of mirror. So which of the following order from the top to downwards? So first of all, you just check here. He finds the image, his head bigger than the normal. So bigger than the normal means enlarged image. Okay, so in accordance with the option you go. So bigger than the normal, so it should be like the mirror, concave mirror, right? Why? Because the concave mirror, it will produces the enlarged image, not the convex, not the plane, right? So option C, the first thing is concave mirror, the image bigger than the normal. Now let's go to the second part. The middle part of his body, body of same size, right? So same size of the image is produced by the plane mirror. The size of the object and the size of the image is same, will be produced by the plane mirror. So second one is plane mirror, right? And the third one part you just see here, his legs smaller than the normal. So smaller than the normal means it is a diminished image. So obviously the diminished image will be produced by convex. So here the order of the special mirror is concave, plane and convex. So option C is the correct answer. Next question. Consider two statements 1 and 2 given below. Statement number 1, a real image is always inverted, and second statement we have virtual image is always erect. So out of these two statements we have to choose which is the correct statement. So here option A is only one is true. No, one is not true. Here both the statement 1 and 2 are true. So here option C is the correct answer. That is the both the statement 1 and 2 are true, because here real image is always inverted and the virtual image is always erect. Next question. A ray of light passes from glass into air. The angle of refraction will be. So here I will just consider one diagram. Okay, let us suppose that this is glass medium, this is air medium. Now the ray of light is passing from glass. This ray of light is passing from glass. So this is the actual path of ray of light. So whenever the ray of light is traveling from one medium to another medium, it's going to bends. It bends. So here glass is the denser medium and air is the rarer medium. So the refracted ray, it bends away from the normal. Okay, it bends away from the normal. So this is the angle of incidence and this is the angle of refraction. So this is the diagram. Now the question is what? The angle of refraction. So this angle of refraction, option A, equal to the angle of incidence? No, because these two angles are not equal. Angle of incidence and the angle of refraction are not equal. Option A is not correct. Option B, greater than the angle of incidence. Yes, this angle of refraction is greater than the angle of incidence. So here option B is the correct answer. Now you can cross check option C also. Smaller than the angle of incidence? No. Option D, 45 degree? No. So here option B is the correct answer. Next question. A ray of light traveling in air goes into water, right? The angle of refraction is what? Okay, so let us consider two medium. One is air and another one is water. Okay, the ray of light is traveling from air. So this is the ray of light is traveling from air to water. So this is the actual path of ray of light. So air is rarer medium, water is denser medium. So the refracted ray bends towards the normal. Okay, the refracted ray bends towards the normal. So the angle of refraction will be option A, 90 degree. No. Okay, so this is the angle of incidence and this is the angle of refraction, right? Option B, we have smaller than the angle of incidence. Yes, option B, that is smaller, this angle of refraction is smaller than the angle of incidence. So option B is the correct answer. You can check for the option C also. Here equal to the angle of incidence. No, this angle of incidence and angle of refraction are not equal. And option D, greater than the angle of incidence. No, the angle of refraction is not greater than the angle of incidence. So here only the option B is the correct answer. Next question. Here we have the speed of light in air. It's the very easiest question. The speed of light in air, it is 3 into 10 raised to 8 meter per second. So option D, 3 into 10 raised to 8 meter per second is the answer. Next question. When a ray of light traveling in glass enters into water obliquely, right? So let us consider two pair of medium. So the ray of light is traveling from glass, so glass to water. So this is normal. Now the ray of light is traveling from glass, so this is actual path of ray of light. So obliquely, so obliquely means it is making something angle. So here the question is what? It is refracted towards the normal. Option B, it is not refracted at all. Delete this option, because whenever the ray of light is traveling from one medium to another medium, it bends. Okay, so it goes along the normal. No, so making something angle, it means it does not go along the normal. Delete the option C also. Option D, you see, it is refracted away from the normal. So here glass and water. So here glass is the denser medium, water is the rarer medium. So whenever the light is traveling from denser to rarer medium, it bends away from the normal. Okay, it's bending away from the normal. So option D, it is refracted away from the normal, is the right answer.